Welcome to Systems Made Clear with Michele, where we make complex systems easier to understand. Today we're exploring Bullseye Routing in Genesys Cloud. In this lesson, we'll walk through how to read a Bullseye routing design, understand each ring, identify the expansion sequence, and distinguish agent eligibility from agent availability. Grab your favorite drink, and let's make Bullseye Routing clear.
Every contact center faces a central routing conflict. You want to connect a customer with the most highly specialized agent available, but you cannot afford to make that customer wait an unreasonable amount of time. If you rely strictly on specialist routing, you risk severe bottlenecks. When those ideal, highly qualified agents are tied up, queue times spike, service level agreements fail, and callers eventually abandon the interaction. The alternative is generalist routing. That eliminates the wait time by pushing the interaction to the first available person, but you sacrifice resolution accuracy and the quality of the interaction itself. Genesys Cloud addresses this exact problem using an architectural framework called Bullseye Routing. Instead of a static pool, Bullseye Routing targets a highly preferred subqueue of agents first. If no one is available, the system automatically and incrementally expands the acceptable selection pool over time. This means you do not have to compromise between quality and speed up front. The routing engine performs an automated, time-based negotiation between the two while the interaction waits. This diagram illustrates the standard Genesys Cloud Bullseye routing model. Notice the center green ring here, labeled A1 through A3. This is ring 1, representing your most targeted, preferred agent pool. When those center ring agents are unavailable, the system utilizes these outer, wider concentric rings as fallback expansion zones. The underlying philosophy is written directly on the model. Begin with absolute precision and only broaden when thresholds demand it. To configure this correctly, you need to understand the precise terminology. First, the queue is the foundational level where the bullseye method is applied, and the interaction is the incoming task waiting for an agent. A ring is a targeted subpool of agents. Genesys Cloud allows you to configure a maximum of 6 of these rings per queue. Next is the evaluation method. This is the specific rule deciding how agents are compared against skill requirements, whether you rank them by skill ratings, require exact possession of all active skills, or disregard skills entirely. Finally, an eligible agent must meet strict criteria. They have to be on queue, available for the media type, not fully utilized, and they must meet the active skill requirements of the currently open ring. Mastering this vocabulary is a prerequisite. You have to understand these definitions before you touch the configuration interface. We've looked at the spatial concept of the rings. Now let's look at the actual chronological progression of an interaction as it waits in the queue. When an interaction enters the queue, Genesys evaluates the ring 1 agent pool. It holds for a set wait interval, here 20 seconds. When that expires, ring 2 is added. Crucially, the pool expands cumulatively. Earlier ring agents remain fully eligible and retain priority. If a highly qualified ring 1 agent suddenly finishes a call while the interaction is waiting in ring 2 or ring 3, the system will immediately route the task to that ring 1 agent. This timeout and expansion cycle cascades sequentially through all of your configured rings, up to the maximum of 6, as shown by these subsequent 25 and 30-second intervals. The interaction simply stops waiting the moment any agent matching the currently expanded ring's evaluation method becomes available and accepts the task. By expanding the pool cumulatively, the system protects your specialist SLA while safely widening the safety net over time. Translating this conceptual framework into the Genesys Cloud user interface requires you to choose between 2 strictly supported configuration paths.
This matrix breaks down the 2 avenues. Option 1, which expands the pool by manipulating the agent population, and Option 2, which expands the pool by manipulating the interaction skill requirements. Option 1 is ring membership. You configure this by assigning distinct users, work groups, or workforce management aligned skill expression groups to explicit numbered rings. Option 2 is skill relaxation. Here, you keep the base queue population broad, but you incrementally strip away required skills from the interaction itself as each ring expires. As a matter of strict governance, administrators must document their intended operating model upfront. You should not mix these two configuration patterns casually within the same queue. Choosing between membership and relaxation dictates exactly how your workforce responds to volume spikes. It is a fundamental business strategy decision, not merely an IT configuration toggle. Looking closer at option 1, this table illustrates how proficiency thresholds are widened at each timeout. Notice how dropping the required skill A level from a 5 down to a 4 and then a 3 creates a cumulatively larger number of eligible agents at each step. To build this, navigate to User Management, select Queues, and open the Routing tab. Select your required scoring method, set routing method to Bullseye, and choose your evaluation method. The critical detail here is that the time intervals for each ring are configured on the Routing tab first, before any agents are actually assigned to them. Once the ring intervals are set, transition over to the Queue's Members tab to assign the actual populations to those defined rings. This interface shows the crucial step. You use these Bullseye ring number input fields to map individual users, work teams, or skill expression groups to their specific tier. You simply repeat this assignment process until every approved ring population is represented in the list. By utilizing option 1, you establish explicit control over exactly which specific workforce teams answer interactions at each stage of escalation. Option 2 takes a completely different path. This chart shows how the interaction drops specific required qualifications at each timeout. By stripping away skill A, then skill B, and finally skill C, the routing engine casts a wider net to find a broader pool of generalists. Because you are manipulating the interaction rather than the queue membership, configuration happens entirely on the Routing tab by utilizing the Skills to Remove on Exit setting for each sequential ring. It is important to note that these removed skills remain attached to the interaction record for historical reporting, but they are completely ignored by the routing engine during the next ring's evaluation. There is a critical architectural constraint here. Standard ECD skill expression filters built in Architect do not function with Bullseye routing. Administrators must use standard queue skills or skill expression groups instead. Once the configuration is saved, the implementation moves to post-configuration validation. An administrator's job is not done until the routing behavior is audited in production. Direct your analysts to use the Queue Routing Performance and Queue Performance analytic views. These tools verify exactly which ring ultimately answered the interactions, providing hard evidence that your design is working. You also need to monitor the queue's transfer percentage closely after implementation. Adding broader outer rings can sometimes increase the rate of agents transferring calls they realize they are unqualified to handle. Ultimately, continuous analytics validation is the only way to ensure your technical configuration actually delivers the intended balance between specialist matchmaking and customer wait times.